an hour or so together talking about discussing the how to use and visualize multiple videos with signals in GlyphWorks, and all this in sync nicely. We got a few stories to tell and a nice use case to demo. So let's start with an agenda. So indeed, we'll discuss the use of videos in engineering applications. Most of this presentation will be using examples from the automotive sector because it's a domain I know well, but also because most of the applications we currently have to do with automotive applications. So forgive me if you're not part of the automotive. Hopefully, it'll be illustrative enough for you to be able to transpose in your and its features and how to use it, etc. And we'll demo in a live session, so you'll see how it works in practice. We'll end up with a question and answer session. Just before we start, let me introduce you Princia. So Princia is a branch of HBK, and we develop softwares to help engineers deliver durable and reliable products. And we have two software brands for this. We got the nCode brand for durability analysis typically, and the ReliaSoft brand for reliability. We also provide training and education, trainings, online classes, and on whether it's on the theory or how to use the software. And we also provide services. We get a material testing lab in the UK, and we have also a solutions team that can help you with asset management, for instance. So in terms of the software we develop, if we look at the ReliaSoft portfolio first, on the left-hand side, you get the reliability analysis tools with Weibull++ and BlockSim. Then you have the reliability management tools. So you want GlyphWorks for test data analysis, ability, and Vibesys for noise and vibe data analysis. Then we get the data management tools, and Akira, for instance, is a web-based portal where you find the data you share with your colleagues and the processes, the flows you share with your colleagues, and you have nice apps to run that very easily in an interactive fashion, etc. It also contains nCode DS for very fast processing of measured data, sensor data in general. So let's focus on GlyphWorks for this presentation, right? Before moving to GlyphWorks, let me just say a word about the fact that, again, we belong to HBK, and HBK is a great provider of sensors and data acquisition tools, right? So this slide just illustrates one application, like for mobile testing, where we find cameras, first of all, and that's the reason why this slide is in there. We can connect one or multiple cameras to our SOMAT XR data acquisition box or our Quantum X data acquisition box, together with sensors, whether we consider our sensor, the sensors we produce, like strain gauge, force transducers, accelerometers, microphones, torque transducers, etc., or other sensors, right? We can also get hold of the network buses like the CAN FD, all this in sync, right? GPS as well, and then the data is sent in a wireless fashion, or we connect to a PC, get hold of the data locally, and we can manage the data in Akira, especially when you have large amounts, many files, many users of that, many consumers of that files, and the actual processing can be done using GlyphWorks or Vibesys or DesignLife or nCode DS. But here I'm insisting on GlyphWorks because if you got video files as well as time series data, then GlyphWorks has this nice video player that I'm going to present that can help you. So in the automotive world, cameras are an ever-growing sensor that you find in modern cars, right? And not only to assist for parking, but they play indeed a crucial role in all the recent safety and comfort and stuff applications, right? So lane departure, forward collision warnings, blind spot warning, driver monitoring system to make sure you're not falling asleep while you're driving, for instance, things like that. But generally speaking, the cameras play this very, very important role in the advanced driver assistance systems, the ADAS. We hear a lot about LiDARs, and they're phenomenal, this phenomenal technology, but it's still very expensive. And sometimes using cameras, you can achieve similar objectives in a much less expensive way, right? And current cars use cameras a lot, again, often coupled with image processing to produce warnings and to help the ADAS control, what's going on in the car. So, for instance, it's cameras that control what's the speed limit based on the traffic signs recognition, right? It's also those cameras that can recognize a pedestrian and alert, warn you, there's a pedestrian about to cross the street or something. So that's what happens within the car. All this goes on board, real time. There's loads of processing going on. Now, in GlyphWorks, what we can do is we can associate the video with the sensor data. So we've got always more sensor data. That's a fact, right? You get hundreds and thousands of channels are readily available, and more with this IoT, all these connected objects, right? Everything's connected and produce data nowadays, right? But we also saw that we've got more and more video. It's quite cheap these days, and you can get quite decent quality videos for not a very expensive price. So the idea is to associate both to get a full or at least better understanding of what's going on in your monitoring test or in your customer mission profiling or even your bench test. You want to understand, looking at the video and the signal, what's causing what, the correlations, the causality, things like that. So, for instance, when you look just at signals, sometimes you see shocks or large vibration levels, and you might wonder, what caused this? Is it signal anomaly, or has something external caused it? Excuse me, just one sec. And similarly, if we talk, if we do a monitoring exercise in a vehicle, for instance, the driver is monitored, and you wonder, how come there's been this line departure? Was the driver distracted or not? What was the environment like? Was it raining? Was it night or day, and things like that? So all these questions can be answered thanks to the video, much in a very easy fashion, right? It's obvious. I'm just stating the obvious here, right? Why did the driver brake suddenly, right? Did he brake because the ADAS didn't do its job, or didn't warn him or something? And now we crossing the line, not only do we want to understand what went on during the test, but we may want to validate that all this onboard processing provided the ADAS system with the right information at the right time. So by looking at with our human eyes, looking at the video and the signals, synchronizing them together, we can validate that all the thresholds, all the settings that were put in the ADAS work as expected. And sometimes you want some control to occur in some situations, but the question is, how often do these situations occur, and how severe are they, and what are their attributes and stuff like this. So again, having all the information can only help you answer all those questions, right? And I will illustrate this in the demo later. So this synchronization between the video file and the sensor signals is done thanks to the video player glyph. It's a fairly recent glyph. And its main feature is that it is capable of displaying simultaneously up to 16 videos within the same glyph, right? So here in this a screenshot, I've got 2 columns, 3 rows, but you can go up to 4 columns, 4 rows, making 16 slots in there, right? And you can play that and you'll see all 16 videos going in perfect sync. And then it can be synchronized with another video player. So you could imagine having 32 videos, for instance, if you had 2 video players, 4x4, all in sync, or it can be synchronized with a GPS trace, with, obviously signals via the cursor tracking, or with gauges or digital readouts. So you can really construct a dashboard on your screen and replay a test where everything is in sync, and you see what's going on at every instant in time, and you can go back and forth and stuff. So it's really interesting. So often the video recording starts at a different time than the signals recording. It can happen if it's not part of the same data hardware, same hardware, where you have 2 different hardwares for signals and videos. Then you have to adjust the start time, right? The base time. So you can do that within this glyph, and also the playback rates can be adjusted. Some of you might know the media display glyph, which is an older glyph. It's been there for years now. So this one still exists. It can also be synchronized with the video player, right? But it's limited now because it can only display 1 video at a time. However, we kept it because of the existing flows that are out there that you might use, right? But also because it's got the ability to play sound. So you can synchronize all those videos with some microphone data that you want to listen to via the media display glyph, and all this synchronized with signals, GPS, etc. So it has its role in GlyphWorks. So as a quick summary here, we believe the video player glyph greatly improves the ability to view multiple simultaneous videos, right? And all this to help you understand or get more insights from the collected data and the tests that you did. So in terms of file formats, like that's a question you might wonder. What are the file formats that we support in the video player? So first of all, let me tell you, the video player uses the FFmpeg libraries, and they're very they're well-known, famous, and they support a very large number of file formats with a very, very large number of codecs. Also, all the most standard file formats are readable, no problem. But we officially support those AVI, MPEG, MP4, which are very, very standard. We support those file formats. We do some tests on those, right? So we officially support those file formats. And we also support the HBK SOMAT SIE file format. And that's a nice one because within one SIE file, you've got both the signals and the videos, and everything is already in sync. And so, for instance, you've got this dual axis cam 01.SIE. If you read it in GlyphWorks, you'll find out that you get a time series area here with the various channels that are within that file, and you also may have some video files. So we support the SIE file as well. More about synchronization. I keep saying it helps synchronize the data, perfect sync, etc., etc. So how does that work? So first of all is based on the fact that when you drag a video into the video player glyph, the first thing it does is it breaks it down into a set of JPEGs, so time-stamped images, if you like, which once played one after another make up the video, right? So we break down every video into motion JPEGs or series of JPEGs, right? And each JPEG goes with a timestamp. And then when you get multiple videos, so you get two sets of JPEGs, depending on the frame rates and the base time as well, they can be time locked or frame locked when you run when you play those videos, right? So let me explain what we mean by time locked or frame locked. Let's first start with the simplest case where the frame rates are identical across two videos, right? So we got video 1 and video 2, same base time, same frame rate. So that's easy. We go into this frame locked mode, and we will display all the images frame by frame in a frame by frame fashion, right? So first image, second image, third image. So that's perfectly synced. There's no delay whatsoever, and it's again, it's the simplest case, no issue. Reality is that we may as well have different frame rates, different cameras in a vehicle or on the test bench or whatever, or different sources, and they have different frame rates. For instance, one video can be 20 frames per second, the second one can be 10 frames per second. So here we are working in a time-locked fashion. So we look first at all the timestamps that are present in those videos, and we list them all there, right, in this table, if you will. So you get all the timestamps, and for instance, 0 second, we've got an image in both videos, right? So we display those images. Then the next time step, we only have an image for video 1. We don't have an image for video 2. So this image will freeze, will be reused here, right? Whereas the first video will see its image updated. At 0.1 second, we've got an image available in both cases. 0.15, we just have an image available for video 1. So it means that you'll have, in this very case, far more refresh, right? Far more updates for video 1 because it's got a higher frame rate than for video 2. But the important thing is that every time you get a refresh, it's in perfect sync, and we do not mix up things, right? And we take all this into consideration. In this very example here, just for explaining, I used multiples, right? But we could imagine having a video at 30 frames per second, or basically the frame rates can be non-multiple. It'll just work the same. We'll look at all the timestamps, and we'll associate the image at every timestamp and make sure that the time vector goes this way, and if there's no image available, then we keep the previous one. And all this is clear to you as a user, because when you're using the video player, you can ask for the frame information to be displayed. It's an optional it's a property, right, of the glyph. So in this example, for instance, I've got one video at 15 frames per second, the second one at 30 frames per second, right? Here I'm displaying the frame number 11, whereas here I'm displaying the frame number 23. You get a corresponding timestamp for this one and that one, and it tells you that this one is as a delay of 33 microseconds. And if you go to the next frame, it might as well catch up and be perfectly in sync, or you've got basically all this information. You know exactly where you are in terms of your image refresh or what, right? So that's about sync, right? So in summary, the video player offers the ability to view multiple videos simultaneously. By multiple, I mean up to 16 video in one glyph, and we support a large number of file formats, all the standard file formats, right? And the video can be played in perfect sync, right? It accounts for multiple frame rates natively. And the last argument here, the video player can be synchronized with other glyphs, such as photo video player, or XY display, GPS display, gauge display, media display, as we saw previously. So far, so good. Okay, let's move now to the live demo, and we'll we'll use a customer usage profile as an example. So say I'm the designer of this really nice bike here. I want to make sure it's resistant, it's solid, it's durable, it's reliable. So what I did is I equipped it with a number of sensors, so accelerometers, strain gauges, but also cameras, right? We got 3 cameras here, a rear camera, a camera on the handlebar, and a camera on the helmet. So I've got 3 videos and quite a few sensors. And the idea is give this bike to a number of users, younger, older, a boy or girl, all sorts of users who will drive it on very different road types in very different conditions, so that you can get a global understanding, a global view on the usage, and get a usage profile, and make sure you design your bike against something that represents, the population of potential users, right? But in this case, we want to make sure, since the bike exists, for instance, we want to make sure, before it say it's a prototype, we want to make sure that it's able to resist to the various use cases it's been designed for, right? So I want to do some analysis. I want to understand the usage statistics. So in average per trip, what's the distance driven? What was the maximum speed? What was the maximum torque? And all that sort of stuff, right? And I want also to identify some events with their severity, and then how many times do they occur in real life, right? And so that I can construct my customer profile, right? Now the challenge was that one event was identified with a high damage, high severity, and I want to understand, is it something normal that I wasn't expecting, but it turns out that it's quite normal, or is it a customer misuse or even customer abuse, right? How should I classify this event, and should I take it into account in my design? How important is it, right? So let's switch now to the software, and let's take a look. Here it is. Can you see that? Can you see GlyphWorks?
Yes.
Good, thanks, Alex. So I've dragged my measurements in there. Let's focus first on the sensors, and I've run a. I'm not going to introduce GlyphWorks. I suppose you guys are familiar with GlyphWorks, but I run a strain life analysis, and here I've got the results of my strain life analysis. And indeed, I see a total damage for this very trip that's higher than expected. I wasn't expecting the high damage. That's a fairly easygoing trip. I wasn't expecting that much of a damage here. It doesn't mean much to you maybe, but once you turn this damage into a fatigue life in hours, you might. It's probably more easier to grasp the fact that, whoa, that's fairly short life compared to, again, my target. My target was much higher than this. So what's going on? I can also see that the max local strain is fairly high here. So how come? What's going on? The nice thing is the strain life analysis gives me additional stuff to help me understand where this high damage comes from. So I've got the rain flow cycle count here, and I've got the corresponding damage matrix. And I see indeed that there's this tiny little cycle lost here that is producing maybe 50% of the damage, right? And this other cycle here that's producing pretty much all the rest. So it's a very localized damage. Now let's continue investigating, and let's have a look at the time correlated damage. In other words, a time series of damage, right? It computes the damage on a cycle by cycle in my signal, in my strain gauge signal, and it's it's showing me when the damage occurs in time. And what I see is indeed I've got high damage concentrated around second 400 here, right? So whoa, something must have happened. Let's look at the signals now, the original signals. So let's see, we've got, that's the strain signal, acceleration signals, X, Y, and Z, and then speed, power, cadence. And if I look at 400 seconds, indeed, it looks like there is a kind of a burst of strain as well as acceleration, but nothing on the speed or nothing seems visible in on the other channels, right? So something local has happened in this huge strain, right? It looks like it's a crack on the road. So I will stop there. I guess you got my point. Gradually, with the tools we have in GlyphWorks, not only do we have the ability to view the signal, zoom in and out, but we can do some analysis and get some metrics like damage, and we can dig further when did occur the damage. With GPS, we can look at where the damage occur, but sometimes it's not sufficient. So if you have the videos, very easily you can go back and forth and zoom in and out and until you understand exactly, providing you had a camera pointing to the root cause, but very easily it can help you, find the root cause of anything that looks suspicious in your signals. I guess that's the objective of this demo here, to show you, the use of